Welcome back, class. Thank you for joining me for 5-4. Today we're going to dive into dividing these polynomial expressions we've been working with. Now, we know two ways to divide polynomials. So today, for our first day, we're going to talk about long division. Now, this is something you hopefully remember from exponential algebra. We touched on it back then, but now we're going to just review it to make sure that we remember the process of how to do this. Now, because it's been quite a while since you've seen long division, we are going to first review how to do it with simple numbers, okay? Now, first of all, you need to know that 515 or 514 divided by 11 can be written like this. That's how to write it in a form where you can long divide it, okay? So what is doing the dividing goes on the outside. What is being divided goes on the inside. Now, I'm going to go term by term. So, first, I need to look at that 51. Now, I need to see how many times does 11 go into 51 without going over. Well, I know that 11 goes into 51 4 times. All right? So now I take that 4 and I multiply it by the 11. So that puts me at 44. And I want to see how close did I get. So I'm going to subtract that off. So I'm going to take 51 and subtract 44 from it. And that's going to give me 7. Now, after you find that number, remember now you pull down the next digit. So I'm going to pull down the 4. And now I need to see, all right, how many times does 11 go into 74? Well, I know that it goes in there 6 times. So now I take that 6 and multiply it to the 11 to show that that got me to 66. And again, I want to see how close did I get. So I'm going to subtract that off. So 74 minus 66, that's going to leave me with 8. Now notice, I have no more digits to pull down, and I can't put 11 into 8. Okay? So what that's telling me is that this is my remainder. Now, if you recall, with a remainder, what that means is that last piece is still being divided. So the answer to 514 divided by 11 is 46 and 8/11. Now the cool thing is when we're talking about long division, we can actually follow that exact same process with long dividing polynomials. So once you have all of that written down and we've refreshed our skills there, let's talk about how to do it with polynomials. So, and again, it's the same process. So, I'm taking 4x squared plus 23x minus 16, and I'm dividing it by x plus 5. Now, again, my goal is kind of the same. I want to remove, this time not digit by digit, but term by term. So the first term I want to eliminate is that 4x squared, all right? And that x is always going to be what's doing the eliminating. So I want to use that x, and I want to figure out what can I multiply it by to cancel off that 4x squared. Well, hopefully you can see the multiplying by 4x will do the trick, because x times 4x will cancel that 4x squared. Well, once I find that 4x, I need to multiply the whole x plus 5 by it. Okay? And when I do, that is what I write right here. Oops. I'm sorry. So, again, all I did is I took that 4x that I just identified and I multiplied that whole thing by it, the whole x plus 5. And now, just like with normal long division, I want to see how close did I get. So once I've found that, I'm going to subtract it off. So the 4x squareds cancel just like they should. Okay, that was our goal. And now we have 23x minus 20x. So that's going to leave me a 3x there. Now another parallel to long division with simple numbers is now we're going to pull down the next term. So now I have negative 6 or 3x minus 16. And now I need to do the same thing. Now I want to cancel off that 3x. Well, canceling off the 3x, again, I have to use that same x to do so. So I need to think, what can I multiply x by to cancel 3x? Well, I need to multiply it by 3. X times 3 will give me that 3x. And once I've identified that, now I'm going to take that 3 and I'm going to multiply that to the whole x plus 5. So that gives me 3x minus 15. I'm sorry, plus 15. Now I'm going to subtract it off to see how close I got. So 3x minus 3x cancels just like we wanted it to. Negative 16 minus 15 is going to leave me with negative 31. Now, notice here, x plus 5 can't go into a constant, and I have no more terms to pull down. So what that means is this is my remainder. So that 31, and remember, the remainder means it is still being influenced by what is doing the dividing. So whenever you hit this point, so that you're down to just a number, and you can't pull down any more terms, that becomes your remainder. And so our final answer to this looks like that. 4x plus 3 minus 31 over x plus 5. And again, I know that long division can be a lot to take in. However, if you kind of follow this step-by-step process, if you really pay attention to what you're doing, these are going to be very doable problems. Now, let's move on to our next example. Now, if you divide two polynomials and the remainder is 0, it means that the polynomial is a factor of the other. So, what this is telling us is if we got a remainder of 0, that means that it actually could have been factored. Now, you won't know until you're done with the process, though. So let's talk over what the process will look like for these two. So I want to use long division to determine if 2x plus 1 is a factor of 6x squared plus 7x plus 2. So let's begin. The first thing I want to do is get rid of that 6x squared. I'm going to eliminate term by term using this process. And the way I'm going to do that is by using the 2x. So what can I multiply 2x by to cancel the 6x squared? And the answer is I can multiply it by 3x, because 2x times 3x gives us that 6x squared. Now I'm going to take that 3x and I'm going to multiply to that whole 2x plus 1. That's going to give me 6x squared plus 3x. And remember, after we do that, now we need to see how close did we get. So I'm going to subtract it off. Well, 6x squared minus 6x squared cancels off. It's done. 7x minus 3x is going to leave me 4x. And then remember, you pull down your next term and get 4x plus 2. Once you've done that, now we do the same process over again. So this time I'm looking at the 4x, and I want to see what can I multiply 2x by to cancel that 4x. Well, if I take 2x times 2, so I put that 2 up there, that'll give me 4x. So I take that 2 and I multiply to that whole 2x plus 1. That's going to give me 4x plus 2. And now we need to see how close did I get. Well, 4x minus 4x, 2 minus 2, that actually does give me 0, okay? A remainder of 0. So that means yes, 2x plus 1 is a factor of 6x squared plus 7x plus 2. Because our answer just looks like that, has no remainder. Now there is one more trick that I need to teach you. So if any term of a polynomial is not expressed, make sure to represent it with a 0 in the long division process. So what do I mean by that? Well, 2x cubed minus 9x squared plus 15. I want you to notice there's no x term there. However, to make sure that we're successful with our long division process, everything lines up right, we have to show that there is an x, there's just 0 of them. Okay? So make sure you hold its place with that 0 term right there. But other than that, this process is exactly the same as what we've been doing before. So, I look at my first term, 2x cubed. And I want to use my 2x to cancel that. So 2x times what gives me 2x cubed? And hopefully you can see 2x times x squared will give me what I need. So I'm going to take that x squared and I'm going to multiply it to the 2x minus 5. That's going to give me 2x to the third minus 5x squared. And now I need to see how close did I get with that. So I'm going to subtract that off. So 2x cubed minus 2x cubed cancels off just like it was supposed to. And now negative 9x squared minus a negative 5x squared. Now here remember, when you're subtracting a negative is the same thing as adding. So really this is saying negative 9x squared plus 5x squared to leave us with a negative 4x squared. All right, and now we pull down our next term, which in this case is just 0x. All right, now I'm going to do the same thing. I want to figure out what can I multiply by to cancel that negative 4x squared. And I'm still using that 2x. Well, 2x times negative 2x will give us that negative 4x squared that we're looking for. So I'm going to take that negative 2x and multiply that 2x minus 5 by it. And that is going to give me a negative 4x squared plus 10x when I distribute that through. And now, once we've identified that, now again, we're going to see how close did we get. Negative 4x squared minus a negative 4x squared. Again, subtracting a negative is essentially adding. So those cancel out. 0x minus 10x leaves us with a negative 10x. Now I'm going to bring down that 15. And now one last time, I'm going to see if I can make this process work. So negative 10x, I need to cancel that using 2x. Well, how can I do that? 2x times negative 5 gives us a negative 10x. So I'm going to take that negative 5 and one last time multiply it to that 2x minus 5. And I'm sorry, I didn't mean for that to go off the screen. So that gives me a negative 10x and plus 25. And now again, I'm going to see how close did I get. So I'm going to subtract it off. So negative 10x minus negative 10x cancels just like we wanted it to. 15 minus 25 leaves me with a negative 10. And remember, when you're left with just a number, that 2x minus 5 can't go into just a number. So what that means is that negative 10 is my remainder. That's left still over that 2x minus 5. So thank you so much for joining me. I know this long division, again, can be a lot. Just please make sure you have all of it written down and then come back prepared to do our practice work in class tomorrow.